Hi everyone, we are team number 10, London Aquatic Center. This is the final presentation. Let's begin. This is the role of our team. As it is the last presentation, we all did our best to gather information, make story, and organize the presentation. First, let's begin with brief introduction. First, we explain the process of soil refreshing. Prior to cutting the soil, they were needed to investigate the soil condition because it could affect the overall foundation process. According to a survey of more than 3,000 holes in order to check the soil at the site, revealed that chemicals, glue, and various other industrial landfill debris contaminate underlying soil and groundwater. In order to retain the contaminated soil, they select soil washing. Method of soil refreshing, also known as soil washing. The process is very simple. As you can see in this video, the polluted soil is scrubbed by water and solvent remover finally get clean soil. The site where construction began through this process is Queen Elizabeth Olympic Park, London E20, United Kingdom. The building was created for the Olympic Games. Currently, only the main building, which is seen as legacy mode, remains. During the Olympic season, there are seats on both sides called wings. The seats were built to be detached from the initial construction. This is the current legacy mode. It has the roof that looks like a potato chip, and many curves has been used as a building designed by architect Zaha Hadid. We'll find out further details of the roof in our first main content. This is the content of our presentation. Our building's main event is the luxurious roof, so we'll begin with explaining roof. And our building is made for the Olympics, so they had to construct the building to serve as swimming pool. We'll explain about this. And finally, this building needs to be maintained well, so we'll explain the environmental control system of this building. Let's begin with the roof. The London Aquatic Center has an undulating wave-like roof, and the inside of the roof consists of trusses. The curved form of the roof is the result of trial which steals the eyes of any pedestrian and the iconic design of Zaha Hadid. But no matter how the design is beautiful and attract many people, if there are no operation functions, it would be failed design. Then, let's find out what function that doesn't make the design to be failed. The answer is in the spectators. And normally, roof is one of white plate, and this roof is supported by columns which screen the spectators to can see clearly the games. If you want to more spectators, you need to make the roof higher, and at the same time, the column would be higher and thicker block the spectators' view. But the London Aquatic Center's roof, which can make to invite more spectators because of undulating wave shape and truss structure. The truss structure doesn't need columns, and the curvature shape, which side parts go up, is able to make every person to see all the way down into the pool. So, they have clear sight and no columns, and that also define what the roof has the undulating wave shape. But this complex truss structure, which spans a column-free area 530 feet long and up to 300 feet wide, can be vulnerable to the bending moment, which causes the collapse of the structure. So, it is necessary to calculate the loading and analyze the truss, whether it adversely affects the building. So, we idealize the complex curvature truss to straight line truss and assume the total weight is W pound per feet. and we can get the reaction force AY and northern support core and BY at the southern retaining wall. After replacing the distributed load, the concentrated load, we can set up some equations to obtain the values of the reaction force AY and BY. Reaction force values and bending moment values were obtained by several equations, and we can get shear force diagram and bending moment diagram. As we can see in this graph, we can see the bending moment has high value compared to reaction forces. After the roof analyzed like this, the roof construction is proceeded with several supplement construction methods. The one is the sliding joint. The connection between the roof and the supports are a sliding joint. This allows for expansion and contraction that occurs in the steel roof structure due to temperature changes. In this video, look like this. If a steel element expands by heat, the joint allows to slide. And if the element contracts, the joint allows to equivalent things. And the other supplement method is compression hoop. The side parts of the roof are arch shaped because the roof going up on both sides. In generally, the arch structure transmits the self-load to bottom. Therefore, the outthrust force occurs at the supports, and it could be problem to the safety. But it can be resolved by compression hoop because the hoop picks up the outthrust force and prevents deformation of the supports. So, the compression hoop is installed at the southern and northern end that support the arch trusses. And finally, the overall roof's construction process carried out as follows. First, the supports are erected and the trusses are installed as supported by temporal trestle. After every truss is lifted up, the temporary trestle is removed because the deflection can occur in long span truss. Now, let's move on to the pool construction. There were two main goals for the pool construction. First, they must prevent the water leakage from the pool tank and water ingress from the surrounding soil. The aquatic center was located beside the river, so preventing water invasion was important. To make shield condition from the surrounding wet soil, they installed sheet pile wall. By doing this, they can make the de-watered ground condition. Second, they must control the water waves at the swimming pool. Because the fluctuating water waves cause a significant effect to athlete records. For example, when soil shake occurs, the pool tanks fluctuate and divert the water waves from quiet to wild waves. So, to prevent these fluctuated water waves and ensure stiffness of pool tank, they installed the tension pile. When there are wind loads from a hurricane or the uplift forces by soil, the structure with only compression piles will be collapsed by the powerful moment. But if the compression piles and tension piles be together, even if there is powerful moment at the tip of piles, the tension piles carry on its role. So, if there is an uplift of soil, the tension piles hold the pool tanks and maintain the quiet water wave for the better competition. And the London Aquatic Centre, they did another method for the quiet water waves. The normal pool has the flat wall which reflects all of the waves produced by the swimmer. The reflected waves interrupt the swimmers, also affect the load. But the London Aquatic Center for the best Olympic Games. They made 12-degree angular groove on the wall. By doing this, the waves in the water gather in groove and reflected to downward by the angular aspect, while does not interrupt the swimmer. There are specially constructed diving boards right beside the pool. We may have questions about how can this building diving board structure can hold out without collapsing by bending moments. To answer this question, we should understand the cantilever structure. If you give a tiny force at the edge, it translates into massive stress at the foundation. To prevent collapsing, make sure that less materials out of the edge and then have increasingly more material as you translate down into the foundation. Diving boards are kind of the cantilever structure, so the engineers tried to design more stable cantilever structure. And let's finally move on to the last content. First, let's see the ventilation system. To understand this system, we must know the air movement strategies of this building. London Aquatic Center tried to make the air move in a certain way. Air is supplied to the major event spaces using oversized ducts below the pool deck, providing the freshest air at the level of highest activity. In addition, the ventilation system employs only low-velocity jets and fans, avoiding drafts and helping to establish both a pleasant and consistent ambient environmental experience. To make the best condition for the athletes, they tried to make fresh air condition, especially for the poolside. This is how it works. First, air is released through vent in the seating wall, and the air is heated by the water-based radiant heating system in the floor. Next, the natural rise that follows allows fresh air to dominate the pool space, while cooler, older air falls and is caught in return duct, which supplies both water and air. Now, let's talk about spectator seating. Each seat is supplied with its own underseat vent, which supplies the desired cool air directly to the individual spectator. The air is cooled with a series of ammonia chillers. As the air gradually rises in temperature, it also began to rise physically and is collected in the larger return vents located at the top of the stands. Low velocity jets at the top of the stands also shoot heated air into the expansive cavity above the pools, which help prevent any unwanted draft in comfort zone. The specified a series of large fans, which together keeps the air into roof cavity circulating until it can be collected and recycled. This air movement prevents condensation and problems with bad air quality. The heating and cooling system work closely with the ventilation and air movement strategies, dividing the building into major zones with different climates needs, including the pool deck zone for the athletes and the spectator zone. Let's focus on the most important zone, facade zone. Detailing the facade, curtain wall was carefully considered both from a structural standpoint and heating and cooling standpoint. The expansive curtain wall had to be self-supported and so a series of enlarged vertical and horizontal moulins which attached steel trusses was implemented, and the heating tubes, which are filled with a water-based solution, are supplied from a mechanical filtration room. It uses pressure to move the water through the tubes, up and down the moulins, and across a few of the larger sternodomes. The water heats up the air at the base of the curtain wall. which then rises until it reaches the top of the water, where it then begins to cool and descend softly back into the interior. This non-stop movement of air also helps to solve condensation problem. The London Aquatic Centre organizes the water system largely two main systems. One is double use of water and another is rainwater system. First, the use of all water in the London Aquatic Centre. The filtration room collects the backwash water, which is the used water at the swimming pool or shower room, and they recover the used water by doing chemical usage and remove particles down to 1 micron. Finally, the room redistributed the water. As mentioned, the filtration room, located at the center, it supplies the used water through the enlarged pipes to each space, which need the water. And the London Aquatic Centre used rainwater and wall slope for the water system. As the following effect, the rainwater flows along the roof and gathers in massive gutter, and it falls into the bottom following the wall slope. The gathered rainwater can also be used to the facility's toilets and the showers, which account for the largest water demand in the facility. Through this system, London Aquatic Centre saves up to 32% water annually. This is the end of our presentation. Thank you for listening our presentation.